Hi everyone, today we are looking at problem 242, valid anagram. So let's start. Question problem. Given to string S and T, return true if T is an anagram of S and false otherwise. Example 1, input S equals anagram, T equals negagram, output true. Example 2, input S equals red, T equals car, output false. Constraints s.length and t.length is a range of 1 to 5 times 10 to the power of 4. S and T consists of lowercase English letter. Follow-up. What if the input contains Unicode character? How would you adapt your solutions to such a case? Alright. Alright. So in this problem, you are given two strings, S and T, and I will check whether if it is an anagram or not. If it is, then we return true. If not, then we return false. Right. I think I understand the problem now. Let me think about possible approaches. So I can think of one way off the top of my head to solve this. So for each string, we could record how many, or we can record the number of occurrences of a particular letter. So let's say the letter is A, then we record the occurrence of A is 1 in the string. And then we also do the same thing for T. In this case, we will see that let's say T is also A, then we see that both have one letter A. And in this case, it is an anagram because both the count of each unique character is the same in both strings. So I think that's the one approach. This solution would be a ON, or in this case, if S and T are lowercase English character, then that will be 26 character from A to Z, meaning that it will be an O26, and we can say it's a O01. So let me rewrite it in our whiteboard. O2 valid anagram given S and T. You want to check anagram true or false. So I'm thinking that we could store the count from character to the count, say number of occurrences. Yeah. Then we count T, and then we can call another arrays called, sorry, count S and count T would have the same number of occurrences, and then we can check from A to Z if the count S of a character is not the same as the one in T, then it's not anagram. Otherwise, it is an anagram. So, and in here we can safely assume that there will be at least one character because of the constraints. And in this here, our complexity would be we would need to create two arrays, each of size at most 26 keys, because we only have 26 characters, 26 letters in English, and all of them are lowercase. That is one optimization that we can do here. So in here we are using two different arrays, but I think we can further optimize it, such as we can just use simply one array, and then we can firstly we use this array to count the occurrences of each letter for S, and then at the end would be we will have the count. We will have the count for each letter, and then when we go through the T string, we could, instead of increasing, we could, instead of using a new array, we can reuse the same array, but then we subtract it by the count instead, meaning that if initially S has A, then T has a also than A, then we increase the count by 1, and then we decrease it by 1 again, which means that it is an anagram because the number of if the count at the end is 0, then we found that either they have the same number of occurrences for letter A, or they don't have any occurrences at all, right? So count, let's say is a char, equals occurrences in S minus occurrences in T. So now we got and then at the end, if the count is all non-zero, I mean the values char not equals to 0 for any chart, then it's not an anagram. So we are not, we basically end up with still O1 space complexity, but it's a bit more efficient than the previous one, right? So I think this sounds reasonable. Does this, do you guys think I should proceed with coding? Does this sound reasonable to you? I am pretty good about this. May I proceed to program? Right. So first of all, I'm going to go through all the elements in S, meaning that I will have a for loop for letter in S. Oh, right, I forgot. So initially I will create a count dictionary. Actually, I can use a Python library. I think it's called default. So I believe it's from collections. It's a Python standard library, so we will import the default dict, and then we can create the default dictionary instead. So count equals default dict of integer, and then we are gonna go through characters in S first. So for letter in S, we will increase the count by one if by one for each letter. Count of letter plus equals 1. Initially it will be 0 because we that's how the default works. And then for letter, and then the second one we were gonna do, I'm going to just implement this in default dict. Start with the function in key count of letter minus equals 1. Yep. So in S we increase it by 1, in key we decrease it by 1 instead. So they have a opposite behavior. And then at the end I'm going to go through all the values in key. So for key, no, let's call it letter. And then we call it letter count in count dot items. Then we check if the letter count is non-zero. Then we return false. Otherwise, if all of them are 0, then it's an anagram, which means that we can return true. Alright, let me quickly walk through the code to make sure I haven't missed anything. First, I'm going to import the default dict, and then I create a count, which is a dictionary of integer. Then I'm going to go, in the next steps, I'm going to go through our input, which is SNT. Firstly, I will go through the character, the letters in S, its character in S, and then record the number of occurrences using count. And at the end, I will have the number of occurrences for each letter inside count. And then I'm going to, the second step is I'm going to go through the character in key. But in this case, in these steps, I'm going to decrease the count instead, so that meaning that I'm reusing the count dictionary, which means I'm using the count dictionary to count the number of occurrences, but then I'm using the negative side instead of the positive side, because the positive side has been used to count the letters in S. And then after I'm through S and T, in the last steps, I'm going to check if there is any outstanding occurrences, or you can say the count in the count dictionary. And if any of it has a value of non-zero, which means that there's a mismatch in the character count, the count of the character. So let's say the count of A is 1, then there is an excess of character of the letter A in S. However, if the count of A is -2, let's say, I'll write it down here. So if count A equals 1, then there is excess A in S. However, if the count of A is -2, there is an excess of A in T. I mean 2 A's in T. Then in this case this is not anagram, and then this is also not anagram. And the case of anagram is when count A equals 0, meaning that actually I should have explained this earlier. I mean the concept of this should be easier. So I'm going to draw a line here. Then let's see. Should be explained earlier before coding. Right? That's a mistake. I mean, you cannot just say in your head without explaining the detail, and then when you code it and then you explain it later, it's not too late. Okay, but anyway, let me go through the explanation again. So count A is 0, then that means either the count in S and T are equal, or there is no, or not exist in S and T, and this both leads to an anagram. Okay. All right. Now let me run through the sample inputs or any edge cases and the edge cases as well. Here is two character. One is anagram, and then T is negagram. So let's count. First of all, we will go through the S. So count A. So 1, 2, 3. Initially, there is count A1, and then there is count N1. Now A becomes 2. Then we have G. there is one G, and then there is R, there is 1, and then A becomes 3, and then M becomes 1. Right, so S. And then let's go to the T and see what it does to the count. A, N, G, R, M. Now it starts with 3, 1, 1, 1, 1. Negative, it updates the N to 0, A to 2, G to 0, and then A again, and then R to 0, and then the A to 0, then N to 0. Then which means that we have come up with an anagram, right? Then the last steps we will encounter that it is an anagram. Now the second example is red and car. So S equals red, T equals car. Now when we go through the S, the car now R 1, A 1, T 1. Now when we go through the T, the count of R A T. Now there is a C here, so C becomes -1, A becomes 0, and then R. No, I'm sorry. So say this is 1, 1, 1. Then this becomes 0, and then R becomes 0. When we go through the count here, in the last steps, we see that there's 0 okay, and then this okay, and then this not okay. Not anagram. Now how about the edge cases? Edge cases. Let's say S Z T A. I think it still works because the count at the end would be Z and A. This is 1, and then this is -1, so not anagram. S is A, T is A, then the count at the end we will have, and then this is 0, 0, which means that this is an anagram. Right? Okay. I think this code should work. Right, now let's go back to the LeetCode pages and enter our program. So you're going to, I'm not sure if LeetCode allows us to do an import here, but let's try it. Collections import default tick. I'm going to create the count equals default tick of integer. Then going to the letter in S, increase the count of letter by 1, or letter in T, count of letter plus, there should be -1, and then I'm going to go to the letter. Actually, it's simpler if we do it this way, so let me do it this way instead. If count of letter is not 0, then it's not an anagram. False. Otherwise, if we go through all the letters inside the count and then all of them are 0, then it is an anagram, which means that we return true. Now, if the interviewer asks me, do you think this can be optimized further? On top of my head, I see that there is one way. So S and T, if the length is different, then obviously there will be an int size character in the longer string. So before anything, we could check whether the length of S is not equals to the length of T. Then we can return false. Otherwise, if the length is the same, then there is possibility that it is an anagram. So we need to check. So let's say the length of S is 3 and then T is 0, then it's not an T. T should be this 1. Then it's not an anagram because S is definitely longer. Then obviously the count is gonna be larger in S. Like, however, if they are the same, like both are the input one S is anagram and T is negagram, then we need to check whether the letter count are the same or not. Okay, I think I'm pretty good with this. I think it should work. So let me run it. Run churn error. Alright, so here should be from. To set. So now let's submit this. Yep, we got a set the answer. Pretty good. I think that's it from this video. Thank you.